So, all right, wind stress is a vector. Okay? Horizontal wind stress we're talking about. And we're usually referring to a reference level of 10 meters above the sea surface, the sea level. Okay, that's what we usually use in oceanographic applications. And that's the data that you usually get. Okay, and you can draw the wind stress vector. And here's one example. You can see in just a certain coastline orientation, okay, and you have a wind stress vector that you can draw. The black arrow is the wind stress vector. Okay? And the orientation of the wind stress vector is based on absolute coordinates relative to the Earth, indeed, relative to north. Okay, so what really matters for the offshore Ekman transport is the relative angle between the wind stress vector and the coastline orientation. And the coastline orientation is shown here, and the coastline orientation is also based relative to north. It's called beta, this angle between the north direction and the coastline orientation, and alpha is the angle between the wind stress vector and the north direction. Okay? And then you can just work out the relative angle. Relative angle alpha star is alpha minus beta. Okay? And this angle, relative angle, is also in radians, okay? And it varies between 0 and 2 pi, but the 0 is the case when the wind stress is aligned. Okay? 0 is the case when the wind stress is aligned parallel to the coastline orientation. You can also have the case where the wind is anti-parallel to the coastline. Okay? Anti-parallel to the coast, and that's where you get the angle pi. Okay? All right, so let's see what happens from here.